So we did this a little bit last time we met, so I'd like to review it just before we go on to for today's material. You remember doing something like this last time? So what do we do first? Subtract 4, because what's our first goal? Isolate the radical, okay? Square root of x minus 3 equals 7. Is the radical isolated? Good. How do we undo a radical? Well, this is a square root, so we want to square it, right? When we square it, what do we square? So like that, we just square it. Oh, both sides, okay? Square it. So both sides are squared. So what do I end up with on the left-hand side? X minus 3. If we square something that is being taken the square root of, we just get what's inside, right? What do we get on the right-hand side? 49. How do we solve for x? Add 3. Add 3. So x equals 52. And then we're done? Oh, we should check. Okay. All right. So 52 minus 3, 49. Square root of 49. 7 plus 4. Does 11 equal 11? Then we're good. Right? So remembering the steps that we talked about, first we talked about isolating the radical, then we talked about eliminating the radical, which is what we did right here, right? And then we solve, and then we check. Remember those 4 steps from last time we met? Okay? So isolate the radical, eliminate the radical, solve, and check. Okay? So here's what's going to be different about today. Ooh, that looks scary. That looks so much harder than last time. Right? Why does it look harder? There's 2 radicals, right? So 2 radicals are always going to be harder, right? Well, like the opposite of that usually, isn't it? Isolate the radical. Well, which one? Well, both if we can. We would always be able to isolate both, but you have to isolate at least one of them. So I would choose this one only because it's on the left-hand side, and I don't read in Hebrew. Okay? So if I choose this one to isolate, okay, done. Now eliminate. How do I eliminate it? It's a cube root, so how do I... Okay, cube it. So if I cube this side, good, have to cube the other side. What happens when I cube something that's being taken a cube root of? Just what's inside. Whoops. Is that easier or harder? That's way easier, isn't it? So if I subtract x from both sides and I add 11 to both sides, oh wow. X equals 6. Way easier. Okay? Does it look harder? Yeah, I agree with you. I agree that it looks harder because there's multiple radicals there. Okay? Now, is this the right answer? Are you positive? We should check it, right? Just in case. 6 minus 5. 1. So we have the cube root of 1. Do we even really need to know what the cube root of 1 is? What if it was like 12? I know it's not 12, but what if it was 12? Would I need to know the cube root of 12? No, I need to know that it's equal to the cube root of 12 on the other side, right? What's 2 times 6? 12 minus 11? Does the cube root of 1 equal the cube root of 1? Now, you and I both know that we know the cube root of 1, right? What times itself equals 1? Well, that's 1. We all know that, right? So we could also say, take this one more step and say 1 equals 1. Yes, I know that's the answer, so that x equals 6 is correct. Okay? But sometimes you might get something like the cube root of 12. I don't have to know what the cube root of 12 is. But it's enough that I know that it better be the cube root of 12 on the other side. Fair enough? Okay? So what happens if it's something like this? Oops. Pretend that's not there. And it's crooked. There. So 2x plus 5, the square root of 2x plus 5 minus the square root of 3x minus 4. Again, a lot of people think this is harder because there's two radicals in it, right? Does that automatically make it harder? No. What's my first step? Isolate the radical. Which one? Don't care. Choose one. Well, I would choose this one because it's first. That means I got to get rid of this one. What would I do with it? Just erase it? Oh, of course not. That's ridiculous, right? How about if we add it to both sides? (2x plus 5 equals the square root of 3x minus 4. Oh, wow. Now it looks exactly like the problem we just did, doesn't it? Do I need to finish this one, or you got it? Finish it? Okay. So what do I do? Square both sides. Why am I squaring it and not cubing it? It's a square root, right? It's a square root. Okay. So I get 2x plus 5 equals 3x minus 4. So how do I solve that? Subtract 2x from both sides. Add 4 to both sides. 9 equals x. Is it right? 9 times 2. 18 plus 5. Square root of 23, right? Minus 3 times 9. 27 minus 4. Square root of 23. Does the square root of 23 minus the square root of 23 equal 0? Then we're good. This is the correct answer. Okay? Now, one thing I'm going to caution you about today is when I do this, and it was something that happened Friday, and I made sure to tell you about it, but I'm going to make sure to tell you about it again today. Okay? Let's say we have x plus 4, square root of x plus 4 equals x minus 10. Tell me again the first step that I have to do. Isolate the radical. Okay, done. Right? It's already by itself on this side of the equal sign. Now what? Eliminate the radical. How are we going to eliminate this radical? Square it. What am I squaring on this side? I'm squaring the whole side, right? I square this whole side. What does it mean for something to be squared? So, is it alright if I just put x squared plus 100? I promise you, if you do that, you will get it wrong every time. That's not a threat, it's a promise. Mathematically, there's no, unless you just somehow get lucky and mess up somewhere else. But people have been doing that today, and so I want to make sure we understand that x minus 10 squared is the same as x minus 10 times x minus 10, which means we have to distribute, right? We have to distribute the x to each one of these terms. When I do that, I get x squared minus 10x. Then I have to distribute the negative 10 to each one of these terms, and I get negative 10x plus 100. So x squared minus 20x plus 100 is what I get for the right-hand side of this equation. Now, what do I get on the left-hand side of the equation? X plus 4. So how do I go about solving this? If there's a squared involved, what do I want to get it equal to? Say 0. Oh, 0, that's right, okay. I want to get it equal to 0 when there's a square involved. Unless it's a squared term equaling just a whole nother constant. But we've got x's in here, we got to be careful of that. Okay? So right now, where we are in our lessons, in our lesson unit order, you really only know one thing to do with our squared here, and that's to factor. So I need to get it equal to 0. So I have x squared minus 21x plus 96. Now, my intention was not to finish this problem. I just totally made this one up in my head. I don't have any idea if it works or not. Okay? My intention was to be able to get to this part, to get this far, to help you realize that if there's a squared term there, and as well as x terms, you got to get it equal to 0. And what would we do from here? Factor. Okay, you'd have to factor this. You could do AC and then B, figure out what those numbers are. Okay, get your factors, solve those factors, substitute it back in to find out if it's a solution or not. Yes or no? Feeling okay about this? Okay, so the only thing we really added today was what to do if there are 2 radicals, either cube roots or square roots. I think even in your homework, there's some 4th roots. So if it's a 4th root, how do you undo a 4th root? You raise it to the 4th power. Okay? Do you have any questions about that?